Okay, so today we look at our last couple tests that we're going to be using, at least in Calc 2 this year, for finding the convergence or divergence of series. The first one is the ratio test. So the ratio test says simply form a ratio, and if that ratio does one thing, it's absolutely convergent. And if that ratio does anything else, it's pretty much divergent unless specifically one thing happens, and then you guys need to fill that in. So I think this should pretty much make sense because it's very similar to some of the other things we've been doing, right? So a sub n plus 1 is the next term after the current term a sub n, right? So the limit you're going to investigate is the limit as n approaches infinity, and you're going to look at the sequence, not the series, right? When we're thinking about a sub n, we're just thinking about the list, not the summation. That's something as we review, you guys are going to have to be very careful about. You don't want to assume that you're thinking series or summation, adding all the terms up when it's actually just thinking about the list. But we do often use, in fact most of our tests use something about the sequence to conclude something about the series, right? So let's keep that in mind. But anyway, if we look at the next term compared to the previous term, and we take that ratio, absolute valued, and that ratio, as you approach infinity, is less than 1, doesn't it make sense that if the terms from the next one to the previous one, if that ratio of those two things as you approach infinity is small enough, then you're going to converge? So I think this should totally make sense. It's very similar to the limit comparison test. It's very similar to geometric series. Very similar to all that stuff, right? Because really this is just like a geometric series. In a geometric series, in fact, you also check to see if something is less than 1. What do you check to see that's less than 1? R. But what is R? R is the ratio from one term to the next, right? How do you get R? If you aren't sure, you take the one term and divide it by the previous one. So this is in fact exactly like geometric series. It's just more general. It's for situations where it's not exactly the same each time, but any other situation. Okay? So really it's something you already know pretty much. What should I put next to this arrow? Gabe was asking me about it a second ago. Ah, good guess, Mr. Schaefer, but it's not that. It's absolutely convergent if the ratio ends up being less than 1 when you take its limit. If the ratio is more than 1 or infinite, then it's divergent. What happens with most of our tests in some situations?
Can't be determined.
Yes, you guys hear Anna? She said can't be determined. So I'm going to say inconclusive. In other words, the ratio test fails. All right?
Use another. So do you want another test?
Yeah, so then try the other tests that we do. The ratio test works on a whole lot of times, though, so it's very, very commonly useful. All right, so this first one, what do you guys think? Let's just look at it and not think the ratio test first. Do you think it's going to converge, diverge? Any suggestions? Ah, I'm hearing converge. That's good. Why are you guys thinking it might converge? The bottom grows bigger, so we can't say that for sure converges, but it's more likely than if the top was bigger, then we could say divergence test, bam, it's not convergent, right? Okay, so let's try the ratio test and see if we can prove it. So I need to form the limit. I need to take the limit as n approaches infinity of right? And now I need to, underneath here, divide by that thing again. But can you guys tell me, just so we can shortcut our work here, if I'm dividing by a fraction, what do I have to do? Of course, I copy dot flip and multiply by the reciprocal, right? So up here, I'm going to have what on top? Yes, okay? So remember, that's just from copy dot flip. You guys tell me what to do.
Cross out a factorial and factorial.
You can do like.
Can't cross out a factorial yet.
Well, you have to like do
n
the
plus 1 times.
Yeah, I can say, well, n plus 1 factorial is really just
n plus 1 times n.
That's what
save some space in writing if we just do that, right? And so that's going to chop out, but simplify one more thing, though, before we continue.
You can.
How can this simplify?
2 to the n times.
Good. That's how I know you guys have learned math. so that you know that step. You guys are like, well, it's an easy step for some people. It's not an easy step. Now we can go like this, right? See what's left. Yeah, that's an easy limit, isn't it? What is it? As n approaches infinity? Is 0 less than 1? So you guys were right. It does converge, and it does so in what fashion?
Absolutely.
Absolutely, which is stronger than conditional
So
convergence.
there's no way for this to converge conditionally. Like,
If it converges absolutely, it also converges conditionally. I mean, absolute is better. Does that make sense? So stronger kind of convergence. So therefore, our series of a sub n converges absolutely by the ratio test. Yay. Let's do a couple more. I would do 3 or 4 and call it good for today. So, how about this one? What's your instinct? Do gut instinct first. It's always good. Diverge. Can we show it with the divergence test? Yes, but that assumes that you know that this grows faster than this, which we went over the other day, right? So that's kind of a touchy-feely kind of argument, right? It's not a proof by any means. So let's use the ratio test on it and just have a little more evidence, shall we? So let's say the limit as n approaches infinity. We're going to have n to the n plus 1. Going to divide by that thing, which is going to do the same flippy type stuff that we did a second ago. Isn't this problem like really similar?
It's an n plus 1 to the n plus 1. N plus 1
N plus
to the n
1.
plus 1.
Yes. Thanks, Gabe. And whoever else. All right, we want to simplify the same way we did the other one? I think so. Can we just go, well, this is that, and this is that? Yeah. Cancel stuff. See what's left. Is that a limit we can do or not?
Yeah. 'Cause, I mean, if you really think about it, yeah.
You could write it like this,
Can you
right?
like pull the n out of them?
That's,
Zero or 0.
no matter what that is, it's always going to be greater than 1. So it does type. So does it go to infinity?
But like the inside.
So no matter what number you use,
The inside is
greater than 1.
We need to like go down.
It's another way to say that inside is just,
So it
isn't this that classic one that we learned before?
It's actually
What's the answer if you remember this one as the classic problem we've done before? E, good. Let's show it again though, just in case. So this, if you remember, just going through that classic logarithmic limit again, you do what next, or can you guys tell me? Clever rearrangement. That is that, right? And now I can L'Hopital. Yes? Because now it's infinity, or no, excuse me, 0 over 0, because the natural log of 1 plus 0 is 1, is a 0. Yeah. Yeah, this is 0 over 0, so I can L'Hopital and get the limit as n approaches infinity of this thing becomes 1 over n squared negative, doesn't it? You good with that? And then this thing becomes
1 over all of the inside.
1 over all of the inside times derivative of the inside is, yes, negative n to the negative 2, right? But now that cancels out. And I would have just said, you guys recognize this was e, but we need to see this argument again. It's an important one. Yes. So this is the limit as n approaches infinity of 1 over 1 plus 1 over n. That goes to 0. This equals 1. So is our test inconclusive then?
No, gotta get E on both sides.
Good. So now the sum that this actually goes to, the limit it goes to is not 1, but e, and e is 2.718,
Which is greater than
which is greater than 1. So just like you guys told me at the beginning, it diverges because of that condition in the ratio test. Fun times. Let's do one. So a second ago, I was asked the question in class, why do you have to use the natural log on both sides here? And of course the answer is you could use any logarithm to bring this power down. So I was thinking about it for a second and I couldn't come up with the answer. I'd never really tried it with another logarithm. And so Gabe Slade tried it and it totally worked out to e still when he used another logarithm. And I think the reason is because of a consequence of the derivative in L'Hopital's rule. So let's just try it with like log base 10 for instance. So we could of course logarithm any logarithm, pass that logarithm inside here because of the continuity of this function. And any logarithm is going to allow you to bring this power n down. So here's what you get if you use log base 10. So you're going to get log of y. And let's see, so then we're going to have the limit as n approaches infinity of n log 1 plus 1 over n. Let's see if we still get e eventually. So now we're going to say, okay, using algebra, go like this. That could be written like that, of course, same idea as before. And now we're going to say, okay, as n approaches infinity, this clearly goes to 1 over infinity, which is 0. And this goes to the logarithm of 1 plus 0, which is 0, so we can L'Hopital it. So right here, we can say it's equal by L'Hopital's rule to the limit as n approaches infinity. Still have the log of y over here. And over here, but with L'Hopital, we're going to have negative 1 over n squared for the derivative of n to the negative 1 power. And here we're going to have 1 over 1 plus 1 over n times chain rule is going to give us negative 1 over n squared. So now we're going to have, this time, since we have the logarithm here, it's going to be 1 over that, and then it's going to be times 1 over the natural log of 10, like so. So now what are we going to have left? So those are going to cancel out right there, and we're going to have the logarithm of y equals, and this is really not dependent on n, so I'm just going to bring it out in front. Times the limit as n approaches infinity of 1 over 1 plus n. Of course, this guy is going to go to 0. So that's really just going to be 1. So it's going to be the logarithm of y. And we've got this constant out in front times 1. So in the previous argument, we e'd both sides and e to the 1 became e. But now we've got this other thing. And you can see that since we have the logarithm base 10 of y, it's going to be a little bit different. So to get rid of that logarithm base 10, instead of raising both sides to the e power, the inverse of natural log, we're going to have to raise both sides to the 10 power and try it that way. So over here we'll get the limit that we assumed, in other words y equals 10 to the power of 1 divided by the natural log of 10. Now that doesn't look very much like e to me. Let's try it in our calculator and see if the calculator says it looks like that. So if we go 10 raised to the power of 1 divided by the natural log of 10, That is indeed, of course, E right there. We could try to use like the change of base formula or something maybe to get what this looks like. So let's think about the natural log of 10. Remember, that's logarithm base E of 10, which by the change of base formula we can write all kinds of ways. My favorite way is to divide out the inconvenient base. So that'd be 1 over the logarithm of E. Let's try that. So that's going to be 10 raised to the 1 divided by, now we've got this, 1 divided by the logarithm base 10 of E, which if we divide by a fraction, we of course reciprocate. So we're going to get logarithm of E over 1, which is of course just that. And of course 10 raised to the logarithm base 10 cancels out, and there we go. We get y equals E, just like we did when we used the natural log in this technique. So I don't think it really matters which log you use over here at all. You can use any log you like.
I think it converges
Why, Katie?
because I have amazing brain power and I just kind of think about it.
Baloney. Why?
Because
Top grows faster?
the top.
That would mean it wouldn't converge then, though.
Well, oh wait,
Power is
no.
always before.
No, never mind, sorry. I think it diverges.
The top is bigger.
Bottom
I
grows
think
a
it
little bit
diverges
faster,
because if you
but-
take, if you Los
I don't think
Pitals
You
it,
could
the
start
limit-
looking at some terms.
If you Los Pitals it, the limit would be,
Think about what
2/3.
Katie's saying. Right now, if you L'Hopital the sequence,
You're gonna
you're going to have to do it several times, right? After doing it several times, though, what's going to happen to this in the product rule eventually? It's going to go away. And then you're going to have power of exponential base 2 versus power of exponential base 3. Because the derivative, remember, of, like, if you take this derivative, you get this. So it keeps getting that and keeps generating that. Whereas this part eventually is just going to disappear. So it actually grows faster on the bottom. The fact that this has a quadratic times it, I know what you guys are saying, as you approach infinity, is negligible, I should say. Let's see if we can. So I think Katie's hypothesis is solid. Let's see if it's right.
Diverge.
I'm not sure. I don't know. I haven't looked at my notes to see. So
I think
Gotta do that,
actually
right?
I rescinded my,
I'm not sure. Let's see. That right? You guys tell me what to put over here.
Three to the,
If we're doing the ratio test, right?
three to the,
So it's
over ends.
over.
Okay. Now you guys tell me what to do next.
Okay, so
Separate the 2 to the n plus 2.
Into what?
2n plus 1 plus 2
Times.
times 2.
Then do the same thing to the 3n plus 1.
3n times 3
Yeah.
times n squared. We kind of forgot the other n plus 1 squared on the top.
Where? Oh, yeah. I need to put that in there still. Where are you confused, Kyle?
That was it. I don't know what the top looks like.
Where'd that go?
Then you do some canceling.
Let's just try that much and see if we have canceled enough. I don't know. Did we cancel enough? Can we cancel more?
It equals 2/3.
Is Katie right? Is it equal to 2/3? Yeah, because if I expand this out, you get n squared plus n plus 1 times 2. Order of magnitude on top is n squared, order of magnitude on bottom is n squared. 2/3. Meaning,
Converges.
well, I should technically say that equals that is less than 1. Therefore, converges. What converges? That's not a sentence. You could at least say that, right? It's not the whole original thing. Okay. I think that's enough to start you guys out. So we'll do maybe one more ratio test, and I'll show you the root test, which works like identically the same kind of way for tomorrow. So you guys want to try a few of these, right? Even if you've got other homework, just do a couple. You don't do a bunch. Do a couple, okay?